Hey guys, welcome to question MM243 of the Maths Methods Fortify study guide. Now we've got this diagram that shows a point X on a circle, so this point here. The circle has its center at point C, 0, 4, and the line along EF goes through point C and is 8 units in length. Awesome. So E to F is 8 units, and this point here starts at 0, 4. Cool. So the angle XCF is theta, so this angle here, where theta is between 0 and pi on 2. The diagram shows the tangent to the circle at X as the line AB, which is perpendicular to CX. Alright, so this line here, AB, is perpendicular to CX. Awesome. So part AI says find in terms of theta the coordinates of point X. Awesome. So first things first is we need to recognize that this bit here is like a triangle, or it is a triangle. So we need to kind of imagine this as point C, this is X, and this as theta. And our horizontal distance is going to be just this point here, because we start at X equals 0 and we go to this point here. And then our Y value of X is going to be this side of the triangle plus 4, right? Because we're 4 units above the axis, because this is 4 here. So that means that this side length here, according to our SOHCAHTOA, is going to be equal to 4 sine theta, okay? And the reason why is because we know that the radius of this circle is 4 units, okay? From E to F, we know is 8 units, which means that our radius is 4 units, and so from C to X is going to be 4 units. So this distance here is 4, which means that this side length is 4, so 4 times sine theta, right? This length here is therefore 4 cos theta because we're adjacent to the angle, which means that our X coordinate is going to lie at 4 cos theta, and then 4 plus 4 sine theta. So this is our total Y value, but our X value is simply just 4 cos theta. So 4 plus 4 sine theta. And this is it. So that's our first and final mark for part AI. All we needed to do was find X in terms of theta, and we've done that, so that's part I. Next part is part AII, which asks us to find the gradient of the tangent AB. So, how do we find the gradient of this tangent? Well, we don't know what this equation is. We don't know what the line is, so we don't know the gradient there. But what we can do is we're going to be able to figure out the gradient of CX, right? Because we know C, we know X, which is this, and because AB is perpendicular to that, we can take the negative reciprocal of that. Okay, so the gradient of, and you'll see what I mean in a second. So the gradient of CX is equal to rise over run, where our first Y value is 4 plus 4 sine theta. A second Y value is 4, so minus 4, over our first X value, 4 cos theta, minus 0. Awesome. And this is AII. This still has 1 mark. Awesome, so from here, the 4 minus 4 cancel to 0, and we end up getting 4 sine theta over 4 cos theta. These 4's can cancel out, and sine theta over cos theta is equal to tan theta. So this is the gradient of CX. Now AB is perpendicular to that, which means that gradient of AB is equal to negative 1 over gradient of CX, which means gradient is negative 1 over tan theta. And that's our gradient of AB in terms of theta. And that's it. So that's our final answer for part AII. Let's move on to part B. Before we move on to part B though, let's do part AII, which is 2 marks. So there's a fair bit of working in this, but I'm not going to show the full working in this video, just for the sake of just making it easy on you guys. But if you want to check out the working, just check out the work solution that you are able to access. So our question asks us, find the equation of the line AB. Awesome. So in order to find the equation of a line, we need the gradient and a point that it goes through, right? So we know that the gradient of AB is negative 1 on tan theta, and we also know that it passes through the point X, which we also know the coordinate of. So for AB, y minus y1 is equal to m outside of x take x1. We know that our our line AB passes through 4 cos theta, 4 plus 4 sine theta, which means that we can sub in these values now. So y minus 4 plus 4 sine theta, which is equal to -1 over tan theta, which is our gradient, outside of x minus 4 cos theta. And this is our first mark. So this is a 2-mark question. Get our first mark by subbing in this into the gradient formula, into the tangent formula. Once we've done that, we can actually go through a whole bunch of rearrangement, and we end up with y equals -x on tan theta plus 4 over sine theta. Again, if you want to check out the full working for this, please look at the work solution. There's so many ways that you can express this. So if you're not sure if the answer that you got is correct, just plug in this equals whatever answer you got into your CAS, and if it's correct, it should say true. So if they're the same thing, it should say true. That's it. So AII is done, and this is our full solution and our final answer. So let's move on to part B now. Part B is a 3-mark question. We're asked to find the value of theta for which the shaded area above is at a minimum and find this minimum area. Awesome. So, in order to find this shaded area, there's a couple of different ways we can do this, but what I'm going to do is take the total area of this large triangle and I'm going to minus the area of this half circle, and that'll leave the shaded area. So, area is equal to the area of the triangle minus half circle. This is actually how I would write this in an exam. So the area of a triangle is half base times height. So half times base times height minus half pi r squared, right? Because we're doing half of the area. But in order to find the base and the height of the triangle, we're going to need to find our distance here, which is going to be our x-intercept at B, and our height here, which is going to be our y-intercept at A. So we know the equation of our AB line, and we also know that we need to find the x and y intercepts, so we can do that. So our equation of our line is equal to -x over tan theta, plus 4 on sine theta. And if we're trying to find the x-intercept, or let's start with the y-intercept. So we let x equal 0, right? So we get 0 over tan theta plus 4 on sine theta, y. Which means that our y value is equal to 4 plus 4 over sine theta. So A occurs at 0, 4 plus 4 over sine theta. That's all good. And now we need to find our B value. So our B value is our x-intercept. So that means that y is equal to 0. So we get 0 equals -x over tan theta plus 4 over sine theta. And what we end up getting is, actually I'll take you through the working. So what have we done? So we've converted, so we're taking this to the other side, so we get x over tan theta, and tan theta is sine on cos, which means when we divide x by sine on cos, we get x cos theta over sine theta, which equals 4 plus 4 on sine theta. From here, we can multiply everything by sine theta to get x cos theta equals 4 sine theta plus 4. And then we can kind of rearrange this to get x equals 4 tan theta plus 4 over cos theta. Awesome. Which means that B occurs at 4 tan theta plus 4 over cos theta. Alright, so now we've got our A and B values, which is exactly what we need to find the area of this triangle, okay? So in order to find the area of the triangle, we can do, let's just do our total area all in one. So our area is our half times our, half times our base, which is our B, so 4 tan theta plus 4 over cos theta, multiplied by our height, which is 4 plus 4 on sine theta. And then we're adding that, taking away the half circle. So we're minusing 1/2 pi r squared, where our r value is 4, right? Because our radius is 4. So we get 1/2 pi times 4 squared. From here, we can kind of expand this out, and we get area is equal to 8 sine squared theta plus 16 sine theta plus 8 over cos theta sine theta minus 8 pi. So this is our area formula based on all of this. And you can plug this into your CAS and get a clean answer. Like, just plug that in and it'll give you something like this. So we know that the area has to be minimum. Actually, did I say where we get our first mark? No. So our first mark comes when we find A and B. So as soon as we find those two coordinates, that's our first mark. We know that the area has to be at a minimum, right? Because that's what we're trying to find. So if our area is at a minimum, that means the derivative of the area is equal to 0. So dA d theta is equal to 0. So what we do is we find our dA d theta in our CAS. I'm not going to write that because I think you guys can just plug this in and find dA d theta. So just plug that in, get your derivative, solve that to equal 0, and that means that theta is actually equal to pi on 6. So we get a pretty clean answer based on that. So that means that theta is pi on 6. That's our second mark because the question asks us for the value of theta, and then it actually wants us to find the minimum area itself. So we know that our area is given by this formula here, which means that if theta is equal to pi on 6, that means that our area is 8 sine squared of pi on 6 plus 16 sine of pi on 6 plus 8 over cos pi on 6 sine pi on 6, take 8 pi, and what we get is 24 root 3 minus 8 pi units squared. So our minimum area is 24 root 3 minus 8 pi units squared at theta equals pi on 6. This area is our third and final mark for part B, and that actually concludes MM243. So I know this is pretty crazy, this stuff, but it actually comes out quite nice in terms of the answer. And you can use your CAS, so make sure you do that. Guys, if you have any questions, please hit me up in the comments below. But otherwise, thanks for watching and have an awesome day.